I am Dr. Narayana Kalkura, UGC BSR faculty, at present working at Crystal Growth Center, Anna University. So we had this project, CEFIPRA project, from 2016 to 2019. So the background of this work starts from 2014, when one of our students, Dr. Shaktivel, when he was a PhD student, he got a Erasmus Mundus Swagata Fellowship in 2014, and he went to University of Montpellier to work under Dr. Mikhael Bechelany to synthesize biomaterials for tissue engineering and drug delivery applications. So that was in 2014. So that was the connection we had with the French team. So he worked on gelatin based materials. So as you know, gelatin is a highly compatible, but it is highly soluble, but its mechanical properties are very low, and it easily gets degraded. So what we were trying to improve its mechanical properties and also engineer its pore size to make it suitable as a tissue engineering scaffold. So that was the work given to Dr. Shaktivel. So he was working on graphene based gelatin materials. So that was the beginning of our collaboration with the French team under Dr. Mikhael. So with this work, as a background, we applied for a CEFIPRA project, and it was awarded in 2016. Then as a continuation of our work, Shaktivel started working on similar materials which can be used for cancer and cancer treatment, and also for drug delivery treatments, and also for tissue engineering applications towards bone replacement. So to use gelatin as a 3D printing material, we used a new technique called sacrificial mold assisted 3D printing technique. That's where use polyvinyl alcohol as the template, which is highly soluble in water. So we made a template out of polyvinyl alcohol and then poured gelatin onto it and stabilized it. Then after that we dissolved the polyvinyl alcohol away, and we got fantastic scaffold containing very stable gelatin, which could be used for biological applications like drug delivery, tissue replacement and all. So that was one of the biggest achievements we had. And also another one is using collagen. Collagen, we used collagen based composites because we had experience of having collagen composites. Collagen is one of the organic component of the bone, and it is very sensitive. So when you take collagen outside, it will get denatured. So whenever you prepare a composite of collagen with any other material, it will get denatured. So we had developed a technique where collagen was in the native state. Using a biomimetic technique, we prepared calcium phosphate collagen composites. Here also we prepared collagen based camphorol, a flavonoid based composite which had collagen in a native state. So these are all some of the research works we did using CEFIPRA, and the contribution by both sides. From French side it was Dr. Shaktivel, and from our side it was Dr. Socrates. They were working in tandem. They beautifully combined their skills and produced 4 research papers in high quality journals, and 4 book chapters, that too in very good publishing agencies, So this project was managed by Dr. Mikhael Bechelany, who is a pioneer in nanotechnology. He has synthesized one-dimensional, two-dimensional, three-dimensional nanomaterials for various applications using electrodeposition, 3D printing, electrospinning, atomic layer deposition and all. He has more than 400 publications, and his H index is 65, and he was the person who was guiding our students at University of Montpellier and Institute of European Membranes. So that's where our students worked, and under his guidance we could get a lot of new results, which led to our project being graded as excellent. So then regarding our students, after they completed, they also got both Shaktivel and Socrates. They got very good training, and also they could handle all major equipments which were not available in India, not in our center, and also he could get first-hand experimental handling of experimental research equipments. So that was helped them after their Dr. Shaktivel. Now he is appointed as a scientist in MATLAB, which is located in Netherlands, and Dr. Socrates, now he is a research scientist at a Biofarm, a company called biotechnological company called Biofarm, which is located in Coimbatore in India. So they are got benefited, and also because both of them did part of their PhD work under the Indo-French collaboration. So it was very good. And regarding the outcome, whatever we have synthesized, so in future whatever we have synthesized, we are now planning to using collaboration. We want to use to market it, and also check its viability in animals and human beings, and also for clinical trials. We are having now collaborations with National Liver Research Foundation, which was established by Dr. Rela, and also Bharat Institute of Higher Education. They are also having a nuclear science group. So we are also planning to irradiate our samples using gamma radiation to change the surface properties without affecting its bulk properties. So now our future aim is to make it clinically available for the patients, for drug delivery and tissue engineering applications. And regarding CEFIPRA, we must thank the administration. So they did help us in all ways. Whenever we had a problem, they could solve us, and also they were reachable.
As sir mentioned, under the CEFIPRA project, we have 5 different experiments that led to 4 research publications. The first one was gelatin and boron nitride scaffolds for bone tissue engineering, where we found there was a 3-fold increase in the mechanical stability of the gelatin when compared to boron nitride incorporation. And the next one was, this was done using electrospinning. And we have one more scaffold using electrospinning with curcumin and doxorubicin that was used for anti-cancer therapy of melanoma cells. And after electrospinning, we went to 3D printing, where 3D printing we had PCL based and PVA based. The PVA based scaffolds, as you can see, had a lot of pores, and it was tunable pore size, and it had a perfect architecture for bone tissue engineering. The PCL scaffolds that were prepared had PCL with silver nitride incorporated scaffolds. So at the site of implantation, there will not be any bacterial activity. So it will have an antibacterial effect. After which we prepared camphorol and collagen scaffolds for bone tissue engineering using a flavonoid. So these were the works that were done under the CEFIPRA project, both in our lab and at Montpellier, France. The raw materials for this project, collagen silver nanoparticles, were prepared here, and this was taken there and incorporated into the 3D printing and electrospun scaffolds.
Long live India and France friendship.